Hello and welcome back. So this is the last part for the activity where we create the secant method to solve the same equation, right? So here we would be creating the secant method. We did the bisection and then the Newton-Raphson in the previous two videos, so if you've not seen them, then go and check them out. Now for the secant method, okay, so let's secant method. Now for the secant method, given a function, a nonlinear function f of x, right, we would need some initial guesses. So we would have to guess x naught, that's the first initial guess of the root, and then another guess x1, right, of the root. And then unlike the Newton-Raphson where we make use of the derivative, here we don't make use of the derivative in the secant method. So for the secant method, then our new root x2 is given as the x naught, right, times f of what, x1 minus what, x1 times what, f of what, x naught, right, all over what, f of x1 minus what, f of what, x naught. So basically this is the secant method, and then we would have to perform this iteratively. So after computing this, we then have to now we would now use what, x1 and x2 in the next iteration instead of the x naught and then x1. So here we would now reassign our x naught. Okay, since we are going to program it in the computer, we would have to reassign our x naught to be what, our x1, and then our x1 to be our what, x2, and then we recompute it. So we'll do this until the tolerance epsilon is reached. So which means that if the functional value of what, f of x2, right, if the functional value of f of x2 is less than the absolute values of the functional value, if this is less than the tolerance, okay, then we break out of the loop, or we stop the loop and then return what, and then we return x2 as our approximate root to the given nonlinear equation. So which means that here too we would be using a while loop, right? You can decide to use a for loop and then perform the iteration some n number of times, or use a while loop and then do it until your criterion is met, and then you break out of the loop. Okay, so now let's go back to our terminal and then see how we can go about this. So we first create our file, this we call it secant.c, right, and then inside it we include the standard input output. So standard input output header, and then we include, since we'll be using the absolute value, we include the math library as well. So standard input, this time math.h, right, and then we will define, we still want to define our function, so we can define what, so this is a macro, we are making use of macros here. So if you want to really get the macros, you can go to where we started with the bisection and then you understand it better there. So this is f of what, x, and then the definition, the macro expansion would be x, the function we are using, so that's x star x star x, right, minus x, then minus 1. So we have that. Since this doesn't make use of the derivative, we wouldn't bother ourselves with the derivatives. So we now declare our int main, but first, before then, let's declare our function prototype. So function prototype, function prototype and then this is, so secant will also return a float, so the name would be, let's call it secant, right? And then this time around we give it a float x naught, right? And then another float x1, and then what, a float tolerance, so tau. So that will be the stopping criterion. Now we can now declare our int main function. Obviously we are returning nothing, so void, and then here we declare our answer, so a float answer that would hold our answer for us. If you like, you can declare it. If you like, you can just compute it straightforward, but it's nothing. So here we want our answer to be equal to what, the return value of our secant method, so secant function, sorry. And then so now let's give it an initial value of let's take initial x to be 1, and then 2 and c. Let's just try these 2 and c, and then a tolerance of 0.0001, and then we print f. So we print our answer, so print f of what, so we say the root is, sorry, the root is, so %f, go to a new line, and then we give it the answer, but we end this line as well. So now we expect this to run. Now let's go down there and then declare our function. If you don't know why we go down to declare the function, go and watch the video on functions, and then you would understand why. So here our function will return a float, so we give it a float. We called it secant in the prototype, so we give it the same name as we gave it in the prototype. And then this will also return a float of x naught. You will take in a float of x naught, take in a float of x1, and then take in a float for the tolerance, so float for the tolerance, right? And then here, now inside the function, right, we check, right? So first we declare our floats as the roots, right, because we'll be returning the roots. And we'll be returning the roots, and I would also need the stopping criteria, so that will be an integer, so int call stop, just to pass it through our while loop. This is just one way of doing it. If you like, you can, there are several ways of doing it. This is just one way of doing it. So, and then now we can now declare our x2, right? So this will also be a float, right? So you can declare our x2 to be equal to what, we can declare our x2 to be equal to, so x2 here. Now we now start our loop, so while the stop, right, is equal to 0, we should execute the code in the curly braces for us. So this code is what we said our x2 should be equal to what, so here we can use two parentheses to separate, to make sure that we divide the two sides. And then here we say that it will be x naught, right? So x naught star the functional value at what, x1, so that will be x1, right? And then minus, so this would be minus what, minus, so if you don't want this to confuse you, you can just put this expression also into a parenthesis of its own, right? and then so minus, then you declare another parenthesis, then you say x1, right, times what, the functional value at x naught. So that's that. And then we come here and then we also do another functional value at, so this will be functional value at x1, right, times the functional value at what, x naught. Okay, sorry, so x naught here. Then we terminate the line, and then from here we say that what, we now, after doing this, we assign a new value, right? So we say that we check if the absolute value, so f abs of what, the functional value at x2, right, if the absolute value of this x2, right, is less than the tolerance given, it's less than the tolerance, right, then we should execute this code. Then we should assign the roots to what, x2, to x2, right, and then break out of the loop. So and then break out of the loop. So this is 1. Now what if the absolute value is not equal to, so we say else, right, else what should happen, so else assign what, your x naught, so your x naught to be equal to x1, right, and then your x1 to be equal to x2. So we are saying that after calculating our new x2 value, right, from the equation for the secant method, we should check whether the functional value at this is either equal to 0 or less than the tolerance. Okay, so here we could decide to add equal to 0 or less than the tolerance. So let's do that. So whether the functional value of this is either equal to 0 or less than the tolerance, right, then if this is true, then it should return that, else then it should reassign the new x naught to be the previous x1 and the new x1 to be the previous x2, and then reuse them in the calculation, get a new x2, and do this until the tolerance or the function, the absolute value, is less than the tolerance. Okay, so let's see how that will go. Let's save this and hope we don't get any error. So we have that. So let's compile GCC. We call this secant, so secant.c. we want the output to be secant.x, right? So we compile. Yes, we don't have any error. So let's see whether our function will run. Secant.x. Interesting. So our loop is not terminating, so let's see where the problem is. So we do Control C again to stop the iteration and then go back to our code to see. So the reason why the loop wasn't terminating was because here we did what, instead of minus I wrote time, so this is supposed to be minus. Okay, so f of x1 minus f of x naught, and then we forgot to return a value here as well. So return, so we are returning the roots. Bear in mind that functions can only return one value from the bag, so, or out of the bag. So return the roots. Now let's save and see what happens. So let's recompile it and then run this code and see. Okay, so now we have an answer to be the root is 1.324718. So basically, yes, this function works, or this code works, and then now we have written a function for the secant method as well. So this brings us to the end of this activity. I would urge you to recreate this activity to answer the second function, or to solve the second function, and then leave your answer, your approximate answer, in the comment section below. Thank you.